half header. So we have created this file and created this circuit name as half header. So if we click on this half header, so I think it is already done in this main part. Uh, Here is the half header, but see this half header is not like our half header. So we can again create a half header. Suppose we are creating add circuit by add circuit. Again we are creating, suppose we have this name that is half A1. So we have to create this circuit here. So now after clicking this editing mode, we have to select what are the gates that we require or what are the input pins we require. So suppose in this way you know how to create the half adder. That is, it's a combination of different gates. But now if we use this path that is from Windows, if we select this combination and analysis, this combination and analysis part, then you can see here that the inputs, output table and expressions are there. So if we put here A, suppose these are the inputs, then we have to take another input B. So click on the add button, and next if we click B, sorry, if we put B as input, then we have to click on the add button. So these are the inputs that A and B. So see the logisim, sorry, see here our inputs are A and B and outputs are S and C. So following this, using logisim, yes, this part. Now we have to click on the output section, and here we have to put our output, suppose S, and another output as C. Okay, next we have to click on the table. So see here, oh, we have not added C. So after putting C as our output, we have to click on the add button. Then we have to click on the third step, that is table. See here the table. Okay, so these tables consisting of the input values, but here we cannot see the value of S and value of C. So we have to put the values of S and C. So see, after clicking on S, its value is 0. So we know that sum is 0, so it's okay. So we should not change it. But if we want to change any value, then we have to click on that and we have to put our 1 from the keyboard. And here for C it is 0. So just click with your mouse. And when you want to change your value from 0 to 1, just you need to click 1 from your keyboard. And for C it is 0. Just click from your mouse. And here the sum is 0 but the carry is 1, so we have to put here 1. So our table is complete. Now build circuit. If we click on the build circuit, see here, use two input gates only or use NAND gates only. So we have to click on this two inputs gate. So it will be automatically, and here we have to put here HA1. Suppose we have put here half adder, for half adder HA and it is 1. So click on OK. So see here, our table is there and this is our circuit of half adder. So using this circuit, we can also generate our full adder. Okay, বুঝতে পারছো? So from Windows, then you have to click on this combinational analysis. Then after generating the truth table and selecting the number of inputs and number of outputs and then generating the truth table, you can easily get your circuit. And why I have used this process? Because I can use the gates and the input output devices from input out from this logisim. But why I have used this software, this path, that is from Windows, I have used the combination analysis path, because this half adder circuit I can use for generating our full adder. Okay, so now we have to add, suppose, to remove circuit. We are removing that half adder, and so now so we can select from HA1 or either from HA1 or from half adder, and we have to create one. We have to create one circuit as full adder. So see here, full adder is there. So now if we click on the half adder and bring it here, so see there is this diagram for our half adder. See here, after clicking or after placing that half adder, that is HA1, okay, you can see here that 4 dots are there, 2 blue dots and 2 red dots. So blue dots are used for representing the input variables and red dots are used for sum and carry. And if you want to change this, the width of this half adder, then you can just click on the half adder and just you can do this circuit appearance. You can click on this circuit appearance. So okay, let it full adder. So now full adder. Yes, we need 2 half adders for generating a full adder. So see here, there are 2 half adders. Now we have to make a label for each half adder. So make a label. Suppose here it is HA1. Okay. and this is make a label HA2, sorry, 2. So this is second half adder. Now we have to take our input in this way, that is A, label it as A. This is our input A, another input as B. So make a label. So we are making a label B and another input C and make a label as C. So A, B, C are three inputs because we are generating here the full adder circuit using half adder. Full adder circuit using half adder. Okay. So now we have to connect our inputs with this half adder. So we all know that input A will go to first half adder, input B also will go to the second half adder input, and our sum will go to, sorry, and carry, that is another input. So okay, let us see our full adder truth table. So see here in full adder we have three variables A, B and C, and our sum is like this. So we have K-map for sum and we have a K-map for carry. So see here the position of different ones and our expression, final expression is A XOR B XOR C for our sum. And our carry expression is like that, that is AB BC plus CA. So if we
হ্যালো ম্যাম,
হুম।
একটা অর্গেট লাগবে ওখানে ম্যাম।
হ্যাঁ, এখানটা এইটা চলে আসছে বারবার, এই যে এইটা ক্যান্সেল করতে হচ্ছে। ও আচ্ছা আচ্ছা, সরি, এডিটিং মোডে। হ্যাঁ, এখানে একটা তো আউটপুট দেবো। So we need to change the input variables. So this is our final carry, and we will have to place this. হয়েছে, এবার হচ্ছে এটা এখানে হচ্ছে a bar b plus a b bar। এখানে পাচ্ছি, আমি এটাকে একটা লেবেল করে দিই। এবার বি এক্সপ্রেশনটা কি ছিল, সামের a bar b bar c plus a bar b c bar plus a b bar c bar plus a b c। আচ্ছা আচ্ছা, আমরা সামই লিখে দিই, sum, and this is carry out or C out. Okay, now if we simulate this, 1 0 0, so sum is 1 1 1, so if both the inputs are 1 1, so carry must be 1 and sum is 0, and if 3 inputs are 1, so sum is 1 and carry is 1. So our circuit is okay. So this is the full adder circuit using 2 half adders. So you have to use this logic for creating, suppose we save this, okay, we have saved this. Now we are creating a new thing. Suppose we are creating XOR gate, 2 input. Our question is, suppose using 2 input XOR gate, we have to design 3 input XOR gate. Okay. So how we have to do this? How we have to do this? So first take this arrow mode, that is or editing mode. Now we have to select this main and we have to create our XOR gate. Okay, using the gates. So either this way or using that Windows combinational circuit, that way also we can create this. So I have shown you that Windows and then combinational analysis way. Now I am showing you this way, but you should not take the LEDs from the input output part, but you have to take the LED part from here, the at pin. So if you select this option, then you can use this circuit in another file. So suppose we are using this, we cannot modify it, the name. No, we cannot add circuit. We are adding circuit. Suppose to input XOR. Okay, two input under two input XOR, we are now taking our inputs A, B. We can make the label as B and it is as A, and now we are taking the XOR from these gates XOR. And suppose we are increasing, we want to increase its size, so we have to select this white part and we have to take as 2 input. So this is 2 input XOR. So this is connected, these inputs are connected, and we have to make a label. Now we have to select this pin, that is tool pin for our output. We should not take LED from this input output part, otherwise we will not be able to use this part in our different circuit. So see here, and this is labeled as C. So now if we use the simulation mode and see, for both the inputs 1 1, the output is 0, and for a single one the output is 0. Okay, sorry, the output is 1. Now we have to use this 2 input XOR in another circuit. So we have to click here and on the main section, and we have to add one circuit. Suppose this circuit, that is 3 input XOR. So now our magnifying glass is on 3 input XOR. So if we click on this 2 input XOR and we have to bring it here, see, it is already come, and see, this is our output, this 1 dot. So now we have to use this 2 input XOR for designing our 3 input XOR. Okay, so we have to take 2. So again we have to click on this and we have to bring another XOR for designing our 3 inputs or, and we have to take these input switches or input pins, suppose A, B and C. বুঝতে পারছো তোমরা? কেউ কি আদৌ শুনছে? কে জানে? এটা কিন্তু খুব ইম্পর্টেন্ট, কিন্তু একটা সার্কিট আরেকটা ফাইলের মধ্যে ইউজ করা হচ্ছে, ঠিক আছে? আমি দুটো টেকনিকই দেখিয়ে দিচ্ছি। একটা হচ্ছে উইন্ডোজ থেকে কম্বিনেশন অ্যান্ড অ্যানালাইসিস পার্টে গিয়ে ইনপুট আউটপুট ভ্যারিয়েবলস গুলো দিয়ে ট্রুথ টেবিল জেনারেট করে অটোমেটিক একটা সার্কিট পেয়ে যাবে। আরেকটা নিজেদের মতো সার্কিট, ছোট সার্কিটটা ডিজাইন করে সেটাকে ইউজ করে একটা বড় সার্কিট করা হচ্ছে, ঠিক আছে? তাহলে এটা কিন্তু আমাদের পরবর্তীকালে যখন বড় সার্কিট আমরা কিছু ডিজাইন করব তখন কিন্তু এটা কাজে লাগবে। আচ্ছা, now we need to connect this for generating our 3 input XOR. So there are 3 inputs A, B and C. First we need to connect this A with the first XOR and this B with the first XOR. So this is our output. Again we need to bring this this is our third output and this is our third input and this is our final output. So we have to take this pin, see here, this is pin, tool as pin, okay? So we have to, we can label this as, suppose XOR output, so it is Y, suppose Y, okay? We need to bring it here and connect this is Y, and we have to put a text. So 3 input XOR using 2 input XOR, okay? বোঝা যাচ্ছে?
Yes, ma'am.
Yes, ma'am.
We have to make a label for every individual IC or every individual input that we are using. So first XOR, 2 input XOR, we have to make a label. Suppose we have made label as XOR 1. So XOR 1. Sorry. XOR 1. Both of them are labeled, but it should be XOR 1 and XOR 2. So we have to take this text mode. Again, you have to select this. It should not be 1. I need to Control Z. So it is now okay. Or if you want to make as label, so you can use the text, but this as a XOR 1, 1, and for this XOR 2. Okay, so this is our 3 input XOR gate. Okay, now see the simulation mode output. So suppose we are putting 2 inputs as 1 1, so XOR output is 0, and if there is odd number of ones, the output is low, and if even number of 1, then output will not glow. Okay, so this is our XOR, 3 input XOR. So we have to save this file as 3 input XOR. Okay, so now we have to design. This is your assignment because today you have to design. I have designed 2 circuits, or actually 4 circuits. So you have to design using this logic uh, a ripple carry adder. Ripple carry adder. Do you know what is ripple carry adder? That I have already told you. See, this part, this is like ripple carry adder. So if suppose you are taking 2-bit triple carry adder, then you have to take A0, B0 and A1, B1 as your inputs, and A0, S1 will be your outputs, and Cin will be C01 or C1, or C0 and C1. Okay, so you have to design this and then you have to show me. কারো বুঝতে প্রবলেম থাকলে বলো, আমি আরেকবার বুঝিয়ে দিচ্ছি। কিন্তু ওটা তোমাদের ডিজাইন করতে হবে, ঠিক আছে? এখনই করতে হবে, করে দেখাতে হবে। স্নেহা, বুঝতে পেরেছো?
Yes, ma'am.
হ্যাঁ, তাহলে এই লজিকটা ইউজ করো। কিভাবে করবে? ফার্স্টে তোমার ধরো হাফ অ্যাডার ফুল অ্যাডারের যে পার্টটা আছে সেখান থেকে তুমি একটা হাফ অ্যাডার নিয়ে নাও, ঠিক আছে?
Ma'am, speak in English.
Okay, first you have to create one file as half adder and you have to design the circuit of the half adder, and as I have used the half adder circuit for the full adder, uh, in this way you have to take different half adders for creating your ripple carry adder, that is RCA. First you have to try, then I will show you. Ripple carry adder. So your inputs will be A0, A1 and B0, B1, and another Cin will be there. So initially you have to take Cin as 0 and then you have to take Cin as 1. First you have to design the half adder. Anyone can share his or her screen? How you are doing?
Ma'am, can you please repeat the process once? First, we have to create half adder,
then you have to take that half adder in another file named as RCA or ripple carry adder. So then use that half adder circuit for generating the ripple carry adder. So in ripple carry adder, if it is asked that you have to design a 3-bit ripple carry adder, then you have to take A0, A1, A2, B0, B1, B2. And if it is asked that is 4-bit triple carry adder you need to design, then you have to take A0, A1, B0, B1, sorry, A0, A1, A2, A3, B0, B1, B2, B3. So in this way, suppose see the Jamboard. There are four variables. There are 4-bit parallel adder. Actually, it is also called ripple carry adder. Can you see the Jamboard? See
Yes,
here.
ma'am.
It is also called ripple carry adder.
Ma'am, how will we use the half adders for this? In this, it is written the
Okay,
full
then use
adder.
full adder. Use full adder. So you have to design first half adder, then full adder, half adder in the full adder. Then you have to design this 4-bit ripple carry adder.
Ma'am, can we do this directly using combinational analysis?
Yes, yes, you can do.
Okay, ma'am. Thank you.
I have shown you 2 steps. Any one you can use. See here, this is half adder using our logic gates. That is XOR and AND. And this half adder, we have designed this half adder using the Windows and combinational analysis. So oh, this is half adder using uh, again today we have designed this using the combination analysis tool, and this is the full adder that we have used or we have designed using the half adder HA1, that is the combination analysis tool circuit.
Hello.
Follow.
Ma'am, how can we make a full adder combination analysis circuit using the half adder circuit we made? That
Hmm.
uh, the full
Ma'am,
adder
in
combination.
the ripple carry adder, only two inputs. We require only two inputs, but full adder carries three inputs. So what do we put on the third input?
Third input will be carry.
For the uh, so there will be another input, A0, B0, and C in.
Yeah, I'm showing you. তোমরা চেষ্টা করো আগে, ফার্স্ট ইউ হ্যাভ টু ট্রাই।
হ্যালো ম্যাম,
হ্যাঁ বলো।
আমি 3 বিটের জন্য করেছি, শো করবো?
করো, দাঁড়াও আমি একটা স্ক্রিন শেয়ারটা বন্ধ করি, ঠিক আছে? হুম। কে শো করবে? Who wants to show? Okay. অনয়।
ম্যাম দেখা যাচ্ছে?
হ্যাঁ দেখা যাচ্ছে। এটা কি দিয়ে করলে?
ম্যাম এগুলো হাফ অ্যাডার এইটা টোটাল 3টে ফুল অ্যাডার টোটাল।
এতগুলো? আচ্ছা, একটা দুটো তিনটে, ঠিক আছে।
3 বিট।
হ্যাঁ, তাহলে আউটপুট হচ্ছে ক্যারি 1, ক্যারি 2, ক্যারি 3, S1, S2। ওকে, ব্যাপারটা বুঝলাম। A0, B0, সিন, আচ্ছা, সিন S1 আউটপুট দিচ্ছে ঠিকঠাক?
ম্যাম শো করাবো?
শো করো। দেখো A0, A1, B0, B1টাকে 1 1 রাখো। তুমি 3 ইনপুট করেছো, ওর জন্যই তিনটে করে এসছে।
হ্যাঁ ম্যাম।
ঠিক আছে, 3 ইনপুট করলে তো হবে। তখন সবগুলো ফ্লো করবে, আর সঙ্গে সিনটা যদি তুমি 1 করো, ঠিকই আছে। ঠিক আছে। তুমি এটা কি কম্বিনেশনাল অ্যানালাইসিস দিয়ে করেছো না নিজে করেছো?
না ম্যাম কম্বিনেশন অ্যানালাইসিস করেছি।
আচ্ছা আচ্ছা।
প্রথমে
তাহলে
একটা হাফ অ্যাডারটা ম্যাম কম্বিনেশন দিয়ে করেছিলাম,
হ্যাঁ,
তারপর এগুলোকে জুড়েছি।
ওটাকে জুড়েছো, ঠিক আছে।
হ্যাঁ ম্যাম।
ঠিক আছে,
স্টপ করে দিই ম্যাম।
হ্যাঁ স্টপ করো।
ওকে ম্যাম, থ্যাংক ইউ।
হ্যাঁ।
হুম।
আচ্ছা, আমি একটু দেখিয়ে দিই। Suppose I'm taking the full adder so I'm bringing it here. Another full adder. So I'm designing for two bit, okay? So suppose here two outputs are there, and in this second full adder we are having two outputs. So now we are taking the inputs. First one is for C in. This is A. This is B. This B0. This is A0. And this is C in. And another input switches as A1 and B1. So now we need to connect this. So A1 will be connected it is two input. Uh, mm, It should be 3 input. Here it is 3 input, but it is showing 2 input. Oh, to full adder. Should be full adder. Yes. Now there are 3 inputs. So we have to connect this A with this, C in with this. Okay. And B with this, B0. So A0, B0 and A1 and see here there are 2 outputs, S and C. So you have to take this C, second output, as the C in or C0 in for the second, and here you have to connect this B1, and from here you will get 3 outputs, and we have to take pins for showing our sum and carry. So we have to make label. This is C2 and this is S1 and this is S0. Okay, so in this way we have 2 bit triple carry adder, 2 bit ripple carry adder circuit. Okay, so now let us check. First, C in should be 0 and A0, B0 is 1, 1. So our sum is now let us see using Jamboard. Suppose we have A0, A1, that is value of A are 1, 1 and value of B, that is B0 is 1, B1 is also 1. So if we add this, so 1, 1 will be 0, carry 1, so 3 ones, so here it would be 1 and another carry will be 1. So let us see. So this is, if we sum is 0 And if we put this value as, this is 110. So it is, the output is 110. That is, the decimal of this output is 6, and this is 11. That is, A1 is 1, A0 is 1, so it is 3, and B0 is 1, B1 is 1, so that is also 3. So 3 plus 3, that output should be 6 in decimal. And in also in binary, see, it is also 110. So our output is, and if we put C in as 1, see, this, the output is 111. So our maximum output will be in in ripple carry adder, 2-bit triple carry adder. If C in is 1, so our maximum output is 7. Okay. So maximum output is 7. That is 111 in 2-bit ripple carry adder. Okay. হ্যালো, আর কেউ ডিজাইন করেছো?
Yes, ma'am, doing it. 2 minutes.
দেখাও।
Yes, ma'am, I have
এটা
designed
বোঝা গেছে?
2-bit.
হ্যালো, এটা বোঝা গেছে?
Yes, ma'am.
So we have used here full adder for generating our ripple carry adder. ঠিক আছে?
Yes, ma'am. Ma'am, should
Okay,
we make 4-bit?
You can make 4-bit also. I am sharing my, I'm stopping my presentation here, so that you can show your presentation. Now you have to show your presentation.
I have made 2-bit,
2-bit, okay, show me.
same as yours.
পরীক্ষার সময় পারবে? এটা কিন্তু তুমি দেখবে আমরা প্রত্যেকদিন যেগুলো করাচ্ছি সবগুলোই যে অ্যাসাইনমেন্টে আছে তা না, অ্যাসাইনমেন্টের গুলো কপিতে লেখার জন্য, কিন্তু ওর বাইরেও আমরা অনেক কিছু করাচ্ছি, ঠিক আছে? সেগুলো প্র্যাকটিস করবে পরীক্ষার জন্য।
Can you see?
Yes, I can see.
Yes, ma'am, this is the circuit. One second.
Okay.
Which circuit, which inputs do you want me to switch on?
সবগুলোই অন করো। সবগুলো অন করলে এই আউটপুট আসছে না তো। Is it okay or not? It should be like this. That is, it should be 7. If we put scene as the scene, that input scene is as 1, and both the other inputs, that is A0, B0 and A1, B1 as 1, the output should be 111. That is 7. Okay.
Okay.
Again,
But
try.
I have used 2 full adders.
Yes, but you have not put your inputs, I think, in the right position or in the right combination.
Okay, ma'am, I will try again.
See your first input, it should be placed above, I think. Okay.
This one, ma'am.
Yes, because see here in the C in as output, that you are putting in the First option, first input in the second full adder. In case of the
Okay,
second
this
full,
one.
yes, it is right. But the first C in, that is A0, B0, and after that C in, it should be
Yes, ma'am.
placed right way. Okay.
Okay, ma'am.
Then the output will be right. Okay. So Deepak Kumar, you have to try the full adder, half adder, all the things, and you have to write in your copy only the half adder and the full adder. Okay. Yes,
Okay,
Aman,
ma'am.
show me.
Yes, ma'am. Ma'am, all the switches are on.
Yes,
So the on color is green.
yes,
So
I can see.
yes,
Yes. All the outputs are 1, 1, 1. So the maximum output must be 7.
7.
Okay.
Yes, ma'am.
Yes. Keep it in your mind. Okay. It's okay. You
Okay,
can
ma'am.
change one variable.
What?
Just A0 or B0. Can you change just one bit?
Hmm.
Suppose 0, 1 and 1, 0. So the output that we know, it should be 1, 1.
Ma'am, but mine is exactly same as his Aman's.
But his output is okay. See, all are glowing. If he changes his input from 1, 0 to 1, all the inputs are 1, then his 3 outputs are glowing. Can you see, Deepak? All are glowing. In Aman's circuit, all the outputs are glowing. That is S0, S1 and C out. Isn't it? It's
Yes,
glowing.
ma'am.
Yes. So you have
Ma'am,
to
but I
change.
have I have used the exactly same thing.
I don't know what is the problem. Your full adder may have some problem. So first check it out. Okay, next. Who wants to show? Ananya.
Ma'am, my roll number 70.
Okay, okay.
My roll number 71.
17 and 71.
Yes, ma'am.
70. 70 and
70.
71.
Yes, yes. Oh, 70 and 71. It is 28. এর আগে একজন কে শো করলে? এর আগে একজন শো করলে কি নাম
ম্যাম
ছিল?
অনয় ম্যাম
অনয়, অনয়। What is your roll number, Onay?
63
63, okay. Ananya, yes. Put the C in as 1. It's okay, but can you change the C in as 1? Yes. Okay, okay, okay. Ananya, your roll number? '61, okay. Next.
Ma'am, can I show?
Yes, Pushmita, show.
Ananya,
Yes.
ma'am,
Hmm.
all are one.
Yes, all are fine, but can you change just one position of A0 from 1 to
Yes,
0
ma'am.
and change C in as 0? So it is uh, 0, 1, 0, 1, 1. So it is 1, 0, 1, 0, 1. Yes, 1, 0, 1. Yes, it is correct. Okay.
Okay, ma'am.
What is your roll number?
66, ma'am.
66. Next. Sneha. Sneha, you can show. Oh, there are different
ma'am.
colors. How can you change the color of wires? I cannot change it. Okay, you have used three bits. Okay, 3-bit triple carry adder. Okay, add 0, 1, 0 with 1, 0, 1. Okay. 4-bit. It is 4-bit. Put all the ones. Put all inputs as 1. Is it glowing? I cannot see the changes of your output. Is there any change? All are blue. Same. Change the input combinations. I cannot understand. Output, all the LEDs are blue. Is it changing its color? The LEDs are changing its color or not? I cannot see any changes. Sneha. Okay, anyone other? Mrinmoy, can you show me your circuit? Mrinmoy? Jeet, are you trying or not? Okay. Shora, Onusri, quick. It is already 4:58. So, quick.
Ma'am, can you see?
Yes, I can see. Oh, make changes of input.
Another change, ma'am?
I cannot see the changes of the LEDs, whether it is glowing or
Ma'am,
not.
it's black.
Okay, so make all the
And
inputs as one.
ma'am, all are one.
Yes, now I can see the changes. Every output are also one, isn't it?
Yes,
Okay,
ma'am.
so it's your roll number, Anusri?
64, ma'am.
64. Okay. Next. Hmm. 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 Okay. Mrinmoy, I can see it. So your roll number?
Ma'am, 81.
81. Okay. Next. Who is there? Saurabh.
Ma'am, I'm
Nilisha.
still doing.
Okay. Another. There were 19 students approximately at the starting of the lab. Now I see there are only 15 people, including me. Shagor, will you show? Shagor, Jeet. Onoy, have you?
ইয়েস ম্যাম, আমি শো করিয়েছিলাম।
আচ্ছা আচ্ছা আচ্ছা, অনন্যাও শো করেছে। আকাশ, আকাশ, where is আকাশ? অভিষেক কুমার সিং, অবনীত কুমার।
Ma'am, I had informed you, na, I am having some
Oh,
problems in my motherboard.
yes. অভিষেক।
হ্যালো ম্যাম।
বলো।
ম্যাম, সাগর জানার নেটওয়ার্ক ইস্যু হচ্ছে, তাই ও আমি করতে পারছি না।
ঠিক আছে, ওকে বলবে করে আমাকে পাঠাতে।
ওকে ম্যাম, ওর ম্যাম 62 রোল।
না দেখালে তো রোল শুনে আমার লাভ নেই।
হ্যাঁ ম্যাম, ওকে ম্যাম, ওকে।
ঠিক আছে। আর অভিষেক কুমার সিং, প্রত্যেকদিন তো ক্লাস অ্যাটেন্ড করছো, একটু চেষ্টা করো, কারো একটা ল্যাপটপ, কারো কিছু জোগাড় করে, কারো মেশিন জোগাড় করে চেষ্টা করো।
Yes, ma'am, yes. Ma'am, my roll number is 85.
হ্যাঁ, তুমি আমাকে জবে জমা দেবে, তখন আমি তোমার সব রোল নাম্বার শুনবো।
Okay, ma'am.
First you have to submit. All the students are submitting, na? I'm giving you attendance, but the extra marks that I'm putting for every day's assignment. So after you submit your assignments or show me your assignments, then I will give you marks. So another anyone? Akshay, কোথায়? কার প্রবলেম হচ্ছে বললে অনয়?
হ্যাঁ
কার বললে প্রবলেম হচ্ছে?
ম্যাম, সাগর জানা।
সাগর জানা, আচ্ছা ঠিক আছে, সাগর জানা। তাহলে এখানে জিৎ আছে, বাকি জিৎ, আর এদিকে আছে অক্ষয়। সৌরভ, are you trying?
Yes, ma'am, I'm creating the 4-bit.
Okay, 4 bit লাগবে না বাবা, 2 bit দেখাও। There is no time.
Okay, ma'am.
Only 2 bit দেখাও, ছোট্ট এক্সাম্পল দেখাও। 2 bit পারলে পরীক্ষার সময় 4 bitও পারবে। Yes. দেখাও। Yes. 4 bit. FA1, FA2, FA3, FA4. Okay, it's okay. Scene is there. A0, B0, A1, B1, A2, B2, A3, B3. Okay. If you design full adder and half adder, then it would be very easy to design this ripple carry adder. Yes. Change the outputs. Make all as one. Okay. So it is 4 bits. So carry, this carry 1, 1, 1, 1, and there is another one for carry. So 5 ones. Okay. Okay, fine. Thank you, Jeet. Next. Jeet, your roll number, please. Next. Sneha, are you doing? Are you making changes in your circuit? Saurabh, where are you? Saurabh,
Yes, ma'am. Just 2 minutes.
quick, quick. It is already 5, 7. Abhijit Kumar. Abhijit, have you shown?
I'm trying facing a bit of issues.
Where do you live, Abhijit?
Ma'am, I'm from Bihar.
Oh, is there any network problem?
No, ma'am, not network problem.
And Sneha, from where you are?
Ma'am from Bihar. Ma'am,
Oh.
can I represent my
Yes,
screen?
yes, you can represent your circuit.
Ma'am, but it is still not glowing.
Not glowing.
No, ma'am.
Why not? Have you placed your pins, that is LEDs, in proper way, in right direction?
Yes, ma'am, I do.
I don't know what is your problem. Okay, can you show me your HA1 circuit or your full adder circuit? Yes, this is half adder. Okay, and full adder. Okay, this is. Why have you connected in this way? The wires are attached with that IC. The connection process is not right for the A and B and C also. Just stop and then you have to connect. Yes. Yes, this part. Oh, your A is not connected properly. Yes, you have to.
Ma'am, it is connected, I think.
No. You have to delete it, and again you have to connect.
Okay, ma'am.
Yes. Now see the output of the full adder. Make all as one. If it is one, then carry. No, there is a problem because your sum is not.
Sum is 1 and carry is 1 also, no?
Carry should be one, no?
Yes, ma'am.
This connection is not okay. Yes. Yes. Now it is connected. Simulation mode.
Ma'am,
Again.
still it is.
Actually.
Ma'am, what is the problem? Actually?
Some এখানে গেল ক্যারির সাথে আর হলো বুঝতে পারছি না হাফ অ্যাডার তো ঠিকই ছিল see the half adder again yes connection the last part
This one.
no yes erase that extra part now change I don't know. Again there is some problem okay again you have to try
Okay, ma'am.
have you connected your LEDs properly
Yes,
the
ma'am.
half other circuit হ্যাঁ যাদের হয়ে গেছে বেরিয়ে তোমরা লিখছো তো সফট কপি লিখে জমা দেবে কিন্তু সাবমিট করবে ল্যাবে গুগল ক্লাসরুমে সাবমিট করবে you have to submit your assignments I have given you some sample copies also
Ma'am, still it is not glowing.
I don't know what is the problem
Ma'am, I will send you.
okay
This.
okay try at your
Okay, ma'am.
to send me the photos okay
Okay, ma'am.
okay so anyone else Abhijit Kumar and Shourab
My roll number is 72.
okay you have to send me sorry and Abhijit Kumar and Shourab Mrinmoy you can leave the class Onoy you can leave